Everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says nearly sorted. So problem is pretty simple, that we are given an array where each element is at most k positive positions away from its correct position in a sorted order. So our task is to restore the sorted order of an array by rearranging the elements in place. And we don't want it to use any sort method, that's cool. So we have this example array where 1 should be at the first place, and it says it's 2 positions away, which is true because it should be on the 0th position. It is on index number 2, so it's 2 position away. Same goes for 2, which is 0 1 1 2, and 4 stays at 3, so it's at max k positions away. And that's how. If it was exactly k positions away, then a mere spherical operation, cycle operation would have solved this problem. But now we need to think something different. So one obvious way, which they have mentioned not to use, was to go ahead and use sort. So no sort explicitly. What should we do? So let's analyze what we are getting first. So we are getting this array. We are fortunate that with a k, okay, so with a k equals to 2, we are fortunate that we don't have to go and iterate entire array. So for an index I, it should be till at I'll say at max at the position of I plus 2. And this is based on the assumption that previous elements are sorted. So now we are moving ahead. So with this array, then if I'm at position 2, I wanted to just go ahead and check 3 and 1, not more. So at any time of comparison or fixation, what should I say, fixation of an element of a number to its index, I want to process only k elements. That is so true, or k plus k elements with the current. So at any point, I have only 2 extras to compare with this, or I would say I have only these 2 elements, or wait a second, case 2, yeah, so only k plus 1, I would say. So I have only these 3 elements to consider, and within these 3 elements, I would be having my appropriate element. So if I'm considering 2, 3, 1, do not assume that this array is so small. Let's consider it so big till 1000. I'm not sure. So only 1, 2, 3 I wanted to consider. And if I'm assuming that I'm not assuming, if I'm dealing with only these numbers, I can very well go ahead and make it well with any kind of operations like priority based, and then I can poll it. So once I poll it, I know that I'm beyond this position and I don't no longer need. Once I'm polling this out, then the 1 would be the topmost priority, and then I would be left with 2 and 3, keeping the rest as intact. Similarly, I will go ahead with further elements, and here for considering these 3 elements, what data structures we will use, we will be going ahead with using only priority queue, also known as heap. So if I'm using these 3, then I would also consider the further upcoming elements which are not yet processed because once I'm removed 2, there are only 2 elements, that is 2 and 3, which I don't want, which I wanted to fill again with one more element, as we removed one element, because at any point of time there should be k plus 1 elements within our heap. That's how we will be comparing current with k on the side. So with this thing in mind, we will be going ahead and populating it, and let's dry run this one first upon how does it look like. Oh yeah, so till now we have 1 3 1 4 3 1 4, and let's not assume the rest of the elements. 1 3 1 4, 1 is fixed right now. Within the heap we have 2 3, and we will again go ahead and add one more element, which would be 4. Now how come this 4 came into picture? So we need to have two iterators, one for insertion, and this would be our iterators, one for insertion and one for keeping track of inserted or process. So one for insertion, one for process, because this is where insertion was happened, and we have inserted, this is where we will be updating the position, and here is what the new upcoming would come in. So I'll mark this an iterator instead of insertion and all, and this would be fine. So once we get 4, our array would look something. Okay, we have implemented this. Array would move forward to, iterator would move forward to 3, position number, index number 1. Now I'm having 2 in the picture. I wanted to insert 2. The best place to insert 2 is ITR. So I would be 1 2 1 4. Again, you would be out of the bound, so you would go ahead and it would see I'm on the end of the list, so no issues. As we have inserted on 2, ITR would be ITR plus plus, we would advance. Right now we have 3 4. Similar technique, we would go ahead 1 2, and within the ITR position we are going to take out 3 and put it over here, and we would have 4. And since we have inserted ITR, we would advance it. Now we have 4, and at ITR's position we would go ahead and insert it, remove 4 and insert it on the ITR's position, which would give us something like this. And right now we have an empty queue. This means that we have a sorted array. No, so far so good. So within only few operations we have did it, although the dry run took a bit of time to understand. So I'll go ahead and quickly initialize what all data structures we'll use. One is a priority queue, which would taking integer. So I'll name it as queue, new priority queue. Next one, we need an iterator ITR, which should start from 0, decides the entry point, decides the completed, or I would say sorted index. We would also have I is equal to 0, or I would say processed, or I would say I decides what all are processed. So initially we want to have populate k elements from the array. So I'll go ahead and take as turn I is less than or equal to k I plus plus. Since I is already initialized, I don't want it to initialize yet again. Now we have to take k elements and enter it into q of a of I. That's how we will go ahead and populate our queue first. So that's what we did earlier. So this is our queue. Now once the queue is populated, now time to feed the appropriate values, and make it sorted bit by bit. So for the timing, what I'll do is for let's say where I am is at I until and unless I is less than a dot length I plus plus. Cool. Pull it apart. What I'll do is a of itr plus plus is equal to q dot pull. Pull it out and insert it new of a of I, because I is the new upcoming thing. Now there might be a possibility that we have few elements within the queue itself. So check for remaining elements within queue. It is something similar what we have did it here, where u, which was our I in this case, I went out of bound. That's how this for loop finished. Then we need to still populate iterator until and unless we are done with the queue. So now checking while q dot is empty. While it's not empty, what I'm going to do is populate itr plus plus with q dot pull. And once we are done with this, we know for sure that we have populated k elements in a priority queue. We have ran it on the fly by removing and populating it back again. And once we know there is no more elements to populate, we will finally go ahead and remove every element from the queue. Once that is done, we are good to say that array A is sorted. So no compiler errors seen so far, and checking with the rest of the test cases also seems fine. Yeah, so this was it. This was a very good problem upon understanding how heap works. Again, it has a topic tags under priority queue, arrays, and sorting. So asked in Google. I'm not sure why they asked this question, but yeah. Anyways, good. So for more information upon priority queue or out of the box algorithms, click the video on your right, and I'll see you in the next one.